Microsoft Azure Virtual Training Day Well-Architected Framework. In this section, we will be covering the last 3 modules of the course. In Module 4, we look at the Operational Excellence pillar. In Module 5, we'll touch on the Reliability pillar. Finally, we'll wrap up with Module 6, the Cost Optimization pillar. In this next module, we will cover the Operational Excellence pillar, so let's get started with Module 4. Now let's discuss the Operational Excellence pillar of the Microsoft Azure Well-Architected Framework. With the Microsoft Azure Well-Architected Framework, you can build workloads with confidence based on proven, deep technical guidance that is actionable and simple to use. Allows you to identify areas of improvement and focus on where to optimize workloads. This framework is at the center of an ecosystem of best practices, documentation, assessments, reference architecture, and design principles. All of this is supported and amplified by partners and services that offer to guide and assist you in improving your workload's quality. The Azure Well-Architected Framework enables you to achieve your business objectives, operationalizing how to design, build, and optimize cloud solutions. Microsoft Azure Well-Architected Reviews provides an evaluation of workloads with gap analysis and identifies areas of where to focus your optimization efforts. Reference architectures help you to build and deploy any workload to scale and meet your business needs. And design principles based on proven practices and design patterns from successful customer and partner deployments. Microsoft Partner and Service offers you support and to help you build effective cloud solutions. After touching on Microsoft's Azure Well-Architected Framework, let's dive in. Operational Excellence offers you the guidelines to create a sustainable application environment by building, deploying, and maintaining workloads and comprehensive automation, monitoring, and testing. Let's dive into the main points on Operational Excellence and first cover application design with DevOps. Azure DevOps consists of a union of people, processes, and products to enable continuous delivery of value to your end users, breaking down barriers between development and operational capabilities. With the proper application design for your business needs, you will be able to integrate all parts of the development process throughout building, deploying, and maintaining workloads. And during the development process, relying on automation opportunities and management tools will help you to improve your confidence in your workloads, health, and performance. Now let's look at the build and release processes in Operational Excellence. From provisioning with infrastructure as code to build and release pipelines with CI/CD pipelines to automated testing, embrace software engineering disciplines across your entire environment. Let's continue delving into the main points on Operational Excellence. Agile build and release processes, from provisioning with infrastructure as code, building and releasing with CI/CD pipelines, automated testing, and embracing software engineering disciplines across your entire environment. This approach ensures the creation and management of environments throughout the software development lifecycle is consistent, repeatable, and enables early detection of issues. Let's look at monitoring tools in Operational Excellence. Implement systems and build processes to monitor, build, and release processes, infrastructure health, and application health. Telemetry is critical to understanding the health of a workload and whether the service is meeting the business goals. Let's continue delving into the main points on Operational Excellence, focused and assertive monitoring. Implement systems and processes to monitor, build, and release processes, infrastructure health, and application health. Telemetry is critical to this process of understanding the health of a workload and whether the service is meeting the business goals. Let's look at monitoring tools in a microservices architecture. You want to enable teams to independently test, deploy, and update their systems on demand without depending on other teams for support, services, resources, or approval. This modular approach allows for autonomy and flexibility. You want to continuously evaluate and refine operational procedures and tasks while striving to reduce complexity and ambiguity. This approach enables an organization to evolve processes over time, optimizing inefficiencies and learning from failures. The goal of workload isolation is to associate an application's specific resources to a team to independently manage all aspects of those resources. Next, what does anticipating and planning for failure look like? Run disaster recovery drills on a regular cadence and use chaos engineering practices to identify and remediate weak points in application reliability. Regular rehearsal of failure will validate the effectiveness of recovery processes and ensure teams are familiar with their responsibilities. Planning for failure is important so that if and when it does happen, you know what steps to take in each scenario. When incidents occur, have well thought out plans and solutions for incident management, incident communication, and feedback loops. Take the lessons learned from each incident and build telemetry and monitoring elements to prevent future occurrences. Planning isn't a one and done exercise. Let's talk next about the process of review and refinement. You want to continuously evaluate and refine operational procedures and tasks while striving to reduce complexity and ambiguity. This approach enables an organization to evolve processes over time, optimizing efficiencies and learning from failures. Operational excellence is an ongoing concern. As your business evolves, you should circle back and review the procedures that you have in place to ensure that they are fully optimized. Continuously evaluate and refine operational procedures and tasks while striving to reduce complexity and ambiguity. This approach enables an organization to evolve processes over time, optimizing inefficiencies and learning from failures. What does the automation checklist look like? Automation should be developed and increased so engineers can eliminate future toil. By reducing toil, engineers can concentrate on innovating business solutions. Here are 3 categories where automation can reduce toil, improve efficiency, and ensure consistency. So here we have automation checklists that help us to reduce toil, improve efficiency, and ensure consistency. We have an infrastructure deployment checklist, we have an infrastructure configuration checklist, and we have an operational task checklist. These are all very helpful because if we can outline and list out what we want to do from an infrastructure deployment standpoint or an infrastructure configuration standpoint or an operational task standpoint, if we have these defined and outlined, it makes it much more easier to codify them. And codifying them absolutely reinforces the goals of automation. Let's look at the infrastructure deployment checklist and think about how these checklist points and how they reinforce the goals of automation. As businesses move to the cloud, they need to repeatedly deploy their solutions and know that their infrastructure is in a reliable state. Declarative infrastructure as code solutions, such as an Azure Resource Manager template, are declarative. You state what you intend to deploy, provide configuration values, and the Azure engine takes care of making the necessary Azure REST API put request. When a task requires repetitive runs, especially over long time periods, an automated system is much better equipped to do this with more predictable results that are error-free. Infrastructure as a code tooling is generally built to be idempotent and deployed often, keeping your code and infrastructure from getting stale and out of sync. Once you have your infrastructure as code configurations defined, you can use them to provision new environments more efficiently. This agility can be enormously helpful when you're testing your solution. For example, you could quickly provision a duplicate of your production environment that can then be used for security penetration tests, load testing, or help a developer track down a bug. In some situations where recovery time may not be time sensitive, infrastructure as code configurations can be used as part of a disaster recovery plan. Let's walk through what the infrastructure configuration checklist looks like. Other configurations, such as installing software on a virtual machine, adding data to a database, or starting pods in an Azure Kubernetes service cluster, cannot be accessed through ARM templates. So these actions will require a different set of tools. We consider these configurations as being on the Azure data plane side. This data plane enables tools to use agents, networking, or other access methods to provide resource-specific configuration options. When deploying to Azure, you may need to run post-deployment virtual machine configuration or run other arbitrary code to bootstrap the deployed Azure resources. Azure Virtual Machines extensions are small packages that run post-deployment configuration and automation on Azure Virtual Machines. Cloud Init can be used for things like software installation, system configuration, and content staging. Configuration management tools can be used to configure and manage the ongoing configuration and state of your Azure virtual machines. 3 popular options are Azure Automation State, Configuration, Chef, and Puppet. Now let's walk through the operational task checklist. Operational tasks can include any action or activity you may perform while managing systems, system access, and processes. Some examples include rebooting servers, creating accounts, and shipping logs to a data store. Azure Automation provides an Azure-hosted platform for hosting and running PowerShell and Python code across Azure, non-Azure cloud, and on-premises environments. PowerShell and Python code is stored in the Azure Automation Runbook. Functions provide a cost-effective, scalable, and event-driven platform for building applications and running operational tasks. Functions support running code in Azure written in C#, Java, JavaScript, Python, and PowerShell. With a consumption hosting plan, you only pay for function execution time. Azure Monitor Autoscale can be used to autoscale virtual machine scale sets, cloud services, app service web apps, and API management services. AKS offers automated scaling components, pod scaling, increasing the number of load balance pods to meet demand, and node scaling, increasing the number of cluster nodes to meet demands. Let's walk through the Azure Well Architecture review. The Well Architecture review provides technical guidance using directed questions to assess your workload's operational capabilities and offers guidance for the next steps of improving quality of your workload. It's very important you sign in with your Azure subscription information to save and track your progress and to incorporate any recommendations already available in Azure Advisor to have a complete view of all the areas you can improve to have well-architected workloads. Let's look at the operational excellence questions next. These are the questions for the operational excellence in the well-architected review. We have selected 3 to walk through with you during the session to show how it's done, what's needed to answer them, and to get the proper guidance. There are 18 questions in the operational excellence review, and all of them are important. We're just choosing a sample here for your reference. At any point, you may click on View Guidance, and that will bring you to the report with the recommendations and guidance based on your responses and the information imported from Azure Advisor. Let's walk through each of these questions. A log aggregation technology such as Azure Log Analytics or Splunk is used to collect logs and metrics from Azure resources. Collecting data with no clear approach to understand it and learn from it to improve the operations of the workload is useless and a waste of time and energy. Consider the different way to collect and interpret this data to maximize its impact. Logging data can provide insights about your applications. It can help you to troubleshoot, improve system performance, and recognize when actions need to be taken. It is vital that application and resource level data be correlated and evaluated together to optimize the detection of issues and then troubleshooting them. Azure Monitor metrics and logs allow you to compare data from different application components to each other and find out dependencies that might have been hidden otherwise. Azure Monitor supports near real-time scenarios, making them useful for alerting and fast detection of issues. With structured logs, it's easier to automate the consumption and analysis of the log data. Instrumentation is a critical part of the monitoring process. The data that you gather by using instrumentation should enable you to assess performance and diagnose problems. And so you answer these questions, and answering these questions helps the Azure Well Architecture review determine where you have gaps. So how do you interpret the collected data to inform application health? From that question, we're asking you sub-questions to determine how well you're doing this. A log aggregation technology, such as Azure Log Analytics or Splunk, is used to collect logs and metrics from Azure resources. So we're asking you this question. And how you answer is to think about which log aggregation technology is used to collect logs and metrics from Azure resources. Azure activity logs are collected within the log aggregation tool. Ask yourself, are you collecting Azure activity logs within the log aggregation tool? Resource level monitoring is enforced throughout the application's resource level monitoring. Resource level monitoring is enforced throughout the application. You ask yourself, is resource level monitoring being enforced throughout the application? Logs and metrics are available for critical internal dependencies. You ask yourself, are logs and metrics available for critical internal dependencies? Log levels are used to capture different types of application events. Different log levels such as info, warning, error, and debug should be pre-configured and applied within relevant environments. The approach to change log levels should be a simple configuration change to support operational scenarios where it is necessary to elevate the log level within an environment. Critical external dependencies are monitored. It's common for applications to depend on other services or libraries, despite that these are external. It is still possible to monitor their health and availability using probes. There are no known gaps in application observability that led to missed incidents and/or false positives. What you cannot see, you cannot measure. What you cannot measure, you cannot improve. The workload is instrumented to measure customer experience. Effective instrumentation is vital to detecting and resolving performance anomalies that can impact customer experience and application availability. Now let's walk through how you're managing the configuration of the workload. Managing all application settings is important when trying to streamline your processes and managing high-performance workloads. Optimal configuration can enable you to quickly detect and correct configurations that could interrupt or slow performance. Use Azure App Configuration to centrally manage application settings and feature flags. This configuration management tool stores the settings for your application and secures their access in one place. Application settings can be dynamically changed without the need to deploy or restart an application. Key Vault is another configuration tool. It reduces the chances that secrets may be accidentally leaked. Use Key Vault to securely store and tightly control passwords and other secrets. If you are using different services, you can securely manage secrets and credentials in Azure Managed Identities. This way, you can authenticate to services that support Azure AD authentication. Cloud-based applications often run on multiple virtual machines or containers in multiple regions and use multiple external services. How do you manage and store all your app's configuration settings, feature flags, and secure access settings? You monitor and take advantage of new features and capabilities of underlying services used in your workload. Azure is continuously evolving with new features and services becoming available, which may be beneficial for the application. Application configuration information is stored using dedicated management systems such as Azure App Configuration or Azure Key Vault. Where is application configuration information stored and how does the application access it? Soft delete is enabled for your keys and credentials, such as things stored in Key Vaults and Key Vault objects. The soft delete feature retains resources for a given retention period after a delete operation has been performed, while giving the appearance that the object is deleted. It helps to mitigate scenarios where resources are unintentionally, maliciously, or incorrectly deleted. Configuration settings can be changed or modified without rebuilding or redeploying the application. Can configuration settings be changed or modified without rebuilding or redeploying the application? Is that true for your situation? Passwords and other secrets are managed in a secret store like Azure Key Vault or HashiCorp Vault. How are passwords and other secrets managed in your environment? Procedures are procedures in place for key secret rotation? Do you have procedures in place for key secret rotation? The application uses Azure Managed Identities. You ask yourself, does the application utilize Azure Managed Identities? The expiry dates of SSL certificates are monitored and there are processes in place to renew them. Are the expiry dates of SSL certificates monitored and are processes in place to renew them? Components are hosted on shared application or data platforms as appropriate. Do application components leverage shared data platforms, such as a central data lake, or application hosting platforms, such as a centrally managed Azure Kubernetes service or app service environment cluster? Shared platforms drive down cost, but the workload needs to maintain the expected performance. Your workload takes advantage of multiple Azure subscriptions. You have to understand the subscription landscape of the application and how components are organized within or across subscriptions is important when analyzing if relevant subscription limits or quotas can be navigated. The workload is designed to leverage managed services. Where possible, prefer platform as a service offerings to leverage their advanced capabilities and to avoid managing the underlying infrastructure. Let's look at the operational considerations you're making for infrastructure deployment. Automating processes will help you avoid errors, prevent fails, and help you deploy infrastructure smoothly. When deploying your infrastructure, use automated processes that you can run on demand and rerun if something fails. After your deployment processes are running smoothly, process documentation can keep them that way. Documentation can be in the form of a repository of categorized automation scripts for quick access, with explanations of parameters and examples of script use. Use infrastructure as code to fully realize deployment optimization, reduce configuration effort, and automate the full environment's deployment. Once deployed, this results in usable cloud services. ARM templates, a native infrastructure as code solution, or Terraform can help you with this. ARM or Azure Resource Manager can also help with configuration drift by reducing vulnerability in your infrastructure. As you provision and update Azure resources, application code, and configuration settings, a repeatable and predictable process will help you avoid errors and downtime. And here are our questions for what operational considerations are you making regarding infrastructure deployment. The entire application infrastructure is defined as code. Application infrastructure defined as code, for example, with ARM templates or Terraform. No operational changes are performed outside of infrastructure as code. Are there any operational changes performed outside of infrastructure as code? Examples would be you're making changes through Azure CLI, through the Azure CLI or the portal. Configuration drift is tracked and addressed. By using tools like Terraform, how does the application track and address configuration drift? That's something you want to think about. The process to deploy infrastructure is automated. Is the process to deploy infrastructure automated? Critical test environments have a one-to-one parity with the production environment. Do critical test environments have a one-to-one parity with the production environment? Direct write access to infrastructure is not possible and all resources are provisioned or configured through infrastructure as code processes. It is recommended that even small operational changes and modifications be implemented as code to track changes and ensure they are fully reproducible and revertible. No infrastructure changes should be done manually outside of infrastructure as code. Okay, in this module, we reviewed infrastructure as code, automated testing, and continuous improvement. This concludes Module 4. We will take a quick 10-minute break and start back with Module 5, the reliability pillar. Welcome back from the break. Now let's jump into the reliability pillar in Module 5. With the Microsoft Azure well-architected framework, you can build workloads with confidence based on proven deep technical guidance that is actionable and simple to use and helps you identify areas of improvement and where to focus your workload's optimization efforts. The framework is at the center of an ecosystem of best practices, documentation, assessments, reference architectures, and design principles. All this is supported and amplified by partners and services offering to guide and assist you in improving your workload's quality. The Azure well-architected framework enables you to achieve your business objectives, operationalizing how to design, build, and optimize cloud solutions. The Microsoft Azure well-architected review provides and evaluates workloads with gap analysis and identifies areas of where to focus your optimization efforts. Reference architectures help you to build and deploy any workload to scale and meet your business needs, and design principles based on proven practices and design patterns from successful customer and partner deployments. Microsoft's partners and services offer support for you and helps you to build effective cloud solutions. With some foundational ideas of what Microsoft Azure well-architected means, let's dive into the framework. Goal and method. Some customers use these terms synonymously. Teasing them apart helps stakeholders to understand goals and methods in separate terms. Just like avoiding change is impossible in the public cloud, avoiding failure is not a reasonable goal. We all need to plan to respond to failure gracefully. The last sentence is key and marks what might need to be an important cultural change in the way people consider reliability. The end goal is not to avoid all failures, but to respond to failure in ways that avoid downtime and data loss. Let's look at a real customer implementation of using Azure PaaS services to build a resilient infrastructure. So here's an example of a company called Push Doctor. Push Doctor found themselves in a particular situation. They're a patient-doctor video consultation platform based in the United Kingdom. They needed highly available and scalable infrastructure that would provide the reliability its patients need to access remote healthcare support on their terms. The solution was to use Microsoft Azure platform as a service resources such as Azure App Service. Push Doctor's platform is now instantly scalable and highly secure with an impressive 49% uptime. And thanks to duplicated workloads, it can seamlessly manage failovers. And what was the impact of this? The impact was that Push Doctor can now match patients with a general practitioner in a matter of hours, helping to potentially save the lives of people who would have otherwise waited much longer for a consultation, a service that has proved invaluable during the COVID-19 crisis. Azure PaaS services, like Azure App Service, solve the customer's pain point. Push Doctor's platform is now instantly scalable and highly secure. Microsoft builds the core platform foundation, but the customer shares responsibility for deploying needed resiliency features and benefits. Microsoft builds and operates the foundation, then customers choose to enable relevant services to help with their resilience needs, and their app effectively sits on top of both. The resilient foundation is effectively Microsoft's considerable investment in the platform itself, the focus of the rest of this presentation. Physical things like our data centers, as well as software things like our deployment and maintenance processes. The resilient services are built by Microsoft, but operated by customers. Although they're not mandatory, they're built into the platform so that customer workloads that need high availability, backup, and/or disaster recovery can get started quickly. Let's start with the resilient foundation. It is what everything is built on top of and is required for any application to achieve resiliency. The services on top, or the capabilities built on that resilient foundation that applications take advantage of, we would talk about ones that give applications DR capabilities and the ability to back up. Finally, the application on top must take advantage of those resilient services to have resilience. The platform has inherent resilience, but true resiliency and getting close to that 100% availability requires the application to be architected to take advantage. Let's look at reliability reviews in more detail. Building reliable applications in the cloud means that you can't prevent systemic failure, rather minimize single instances. In the cloud, we acknowledge up front that failures will happen. The goal is to minimize the effects of a single failing component instead of trying to prevent overall failure. Let's review the main points for design for reliability, test for availability and resilience, and monitor and diagnostics. So designing for availability, you absolutely want to use availability zones. This is the idea that we have clusters of data centers that are set up for high availability within a single region. You absolutely want to design your applications to operate when they're impacted by failures. And one of the ways you can do that is to use PaaS services that have this availability built into them. And obviously, you want to validate that you have the required capacity and it's within the Azure service scale limits and quotas. Each subscription has limits and quotas. You want to make sure you're operating within those. Testing for overall availability and resiliency. You have to test regularly to make sure that you're hitting your assumptions and your thresholds and your targets so that you're not going over them. You also need to verify on a regular basis how the end-to-end workload performs under failure conditions. You want to test your application, see what it does when something fails. You want to conduct load testing. Some errors only show up when your application is under a certain load. And you want to perform chaos testing. You want to inject faults. You want to see what happens when a server goes down or a database goes down. And once you set everything up, you have to monitor. We've got it all built the way we want it, and now we want to monitor it to make sure it stays in that particular state. And we do that by monitoring and diagnostics. We can define alerts that are actionable. We want to know when our application is reaching the threshold for load so that we can respond to it. We want to be able to alert and take action to mitigate the issue. We can create alerts as well that poll for services that are nearing subscription limits and quotas. We want to know if we are, before we provision a resource, if we're bumping up against a subscription limit. And we want to use application instrumentation to detect and resolve any abnormalities that are going on in our application. And we're making the distinction here between your application, your code, and your Azure resource. And then we're going to troubleshoot issues, right, to get a good idea of application health. We want to always troubleshoot issues to find out what's going on when we see symptoms. Let's talk about the reliability principle and designing the applications to be resistant to failures. Building reliable application requires failure-resistant design, maintaining uptime and balancing high resiliency, low latency, and cost. Reliable applications should maintain a predefined percentage of uptime, availability, balance between high resiliency, low latency, and cost. High availability and be able to recover from failures, resiliency. This takes into account using availability zones, designing for failure recovery, and a criteria for improving application reliability. You want to use availability zones within a region. If greater failure isolation and availability zones can offer is needed, then you want to consider deploying your application or your workloads to multiple regions. Multiple regions should be used for failover. When your application is unhealthy in one region, you can fail over to another region. Additionally, you can use a service called Azure Site Recovery, but there are additional costs associated with that. Designing for failure recovery, you want to architect your applications to be resilient so they can recover gracefully from failures. You also want to define an availability strategy to be able to capture how the application remains available when in a failure state. And you want to define a business continuity disaster recovery strategy for the application and its key scenarios. You want to have a plan in place, and you want to have a process in place so that if an availability zone or a region of Azure goes down, how do you recover? And then coming up with your criteria for improving application reliability. One of the first things you can do is use a PaaS service. Use a platform as a service offering that has native resiliency capabilities built in to support your application reliability. You also want to design your application to automatically scale, or what we refer to as auto scale, in response to certain conditions in your application. You can do this with Azure Monitor, auto scaling, and load balancing. And again, you want to review your Azure subscription and service limits to validate that required capacity is within quotas. You don't want to bump up against a limit that causes an issue in the operation of your application. Let's talk next about the reliability principle. Define, automate, and test operational processes. Operational processes for application development, in other words, roll forward and roll back, should be defined, sufficiently automated, and tested to help ensure alignment with reliability targets. Testing, responding to failure, and backup and disaster recovery is key to this principle, to defining, automating, and testing operational processes. So looking at it from the end-to-end workload testing, you want to incorporate and do all kinds of testing. As you move into a situation where you're using automation, testing should be included as part of that automation. So you want to do simulation testing, fault injection testing, and load testing. These are all different kinds of testing that allows different kinds of errors to emerge. Building high availability and resiliency testing into your strategy, right? You want to be able to have your resilient application architectures. They should be designed to recover gracefully from failures. You want to define an availability strategy to capture how the application remains available when in a failure state. And you absolutely want to have a business continuity disaster recovery strategy. And you want to automate your testing across your business continuity and disaster recovery strategy and prepare for failure. You should have a complete plan to test a disaster recovery plan. There's no point in having a recovery plan that you have not exercised and yet you don't exercise regularly to show that it works. You want to perform an operational readiness test for failover to the secondary region. Test these processes. You have them in place, test them to make sure that they work. And you want to codify the steps required to recover a failover. We're back to infrastructure as code and declarative programming from an ARM template, for example, to codify the steps that are required to recover from a failover. Let's learn more about define, automate, and test our operational processes. Monitoring and measuring the application availability is important to move overall application health and progress towards defined reliability targets. Let's look at alerts and dashboards to help us respond to failure and look at considerations for improving reliability. So there are some Azure services and resources that you can use to do this. Alerts and dashboards. We have Azure Service Health, we have Azure Resource Health, we have Azure Dashboards. Azure Service Health lets you know when there's an issue with the Azure service. There's nothing wrong with your application, but perhaps there's an outage or something going on with a particular Azure service. Azure Resource Health gives you information about the health of an individual resource that may be having a problem, that may be part of your workload. And you can incorporate Azure dashboards to get a one-stop shopping view of data from services like Application Insights, Log Analytics, Azure Monitor Metrics, and Service Health. Scaling your subscriptions and service targets is also important under this principle of defining and automating and testing your operational procedure. You want to make sure that you know about it if your application requires more storage accounts than are currently available in your subscription. You would have to create a new subscription because of subscription limits to add those additional storage accounts. You also want to be able to do things like identify scalability targets for your virtual machines, including the size of your virtual machines, how many disks are attached to that virtual machines, how much memory, how much CPU is set up for that virtual machine. And you want to avoid data throttling. Review things like your Azure SQL database requirements to ensure that they are adequate for your workload needs. And then finally, fully test your business continuity and disaster recovery plan. Create and fully test your disaster recovery plan. I cannot emphasize that enough. Examples of DR plans that were set in place, never tested, a disaster occurred, the plan did not work because it was never exercised or tested, and it was a true disaster. You want to perform operational readiness tests for failover to that secondary region. If you're going to be failing over outside of a region, if there's an issue with the availability zones, you want to have another level of resiliency, and again, codifying the steps required to recover. You want to put these in an ARM template or perhaps an Azure blueprint. You want to use automation, declarative programming, so that the failover process itself is automated. Let's learn more about the Microsoft Well-Architected Review for Operational Reliability. This review adds technical guidance using directed questions to assess your workload's operational capabilities and offer guidance for the next steps of improving your workload's quality. It is very important you sign in with your Azure subscription information to save and track your progress and to incorporate any recommendations already available in the Azure Advisor to have a complete view of all the areas you can improve to have well-architected workloads. Let's look at the reliability questions next. These are the questions for reliability in the well-architected review. We have selected 3 to walk through with you during the session to show how it's done, what's needed to answer them, and to get the proper guidance. There are 13 questions in reliability, and all of them are important. We're just choosing a sample here for reference. At any point, you may click on View Guidance, and that will bring you to the report with the recommendations and guidance based on your responses and the information imported from Azure Advisor. Let's walk through each of these questions. Let's discuss what availability targets are and how they should be defined to ensure the application is reliable according to business needs. In the cloud, we acknowledge up front that failures will happen. Instead of trying to prevent failures altogether, the goal is to minimize the effects of a single failing component. Use metrics to determine if your app will be within an acceptable time frame for your workload to be unavailable in a disaster. Just as important is how much data is acceptable to lose. The critical nature of your application will help you determine the right levels. Other key metrics are the average time it takes to restore after failure and how much uptime there is between failures. Use these metrics to help find service level agreements or SLAs that meet business requirements. A clearly defined SLA not only guarantees uptime, but also outlines credits in case of downtime. If you are using many services in an application, using a composite SLA can save you money. Availability targets, such as service level agreements and service level objectives, and recovery targets, such as recovery time objective and recovery point objectives, should be defined and tested to ensure application reliability aligns with business requirements. Now let's get to the question, what reliability targets and metrics have you defined for your application? And here's our first statement. Recovery targets to identify how long the workload can be unavailable, recovery time objective, and how much data is acceptable to lose during a disaster recovery. Recovery targets to identify how long the workload can be unavailable, recovery time objective, and how much data is acceptable to lose during a disaster, recovery point objective. Have RPO and RTO targets been defined for the application in key scenarios? Recovery time objective, the maximum acceptable time an application is unavailable after an incident. recovery point objective, the maximum duration of data loss that is acceptable during a disaster. Availability targets such as service level agreements and service level objectives. Have availability targets been defined for the application and key scenarios, and are targets considered whilst the system is running in a recovery mode? Availability metrics to measure and monitor availability, such as mean time to recover and mean time between failure. Are availability targets measured and monitored? Mean time to recover, the average time it takes to restore a component after a failure. Mean time between failures, how long a component can reasonably expect to last between outages. Composite SLAs for the workload derived using Azure SLAs for all relevant resources. Has a composite SLA been calculated for application and/or key scenarios using Azure SLAs? SLAs for all internal and external dependencies. Are SLAs defined and measured for third-party dependencies? Independent availability and recovery targets for critical application subsystems and scenarios. Has the application been decomposed into distinct subsystems with independent availability and recovery targets? Failure is going to happen. That's a fact. It's the application or workload owner's responsibility to ensure it recovers gracefully and in line with reliability targets. Resilient application architecture should be designed to recover gracefully from failures in alignment with defined reliability targets. And here are some of our statements to help you answer this question. Is your application deployed across multiple regions? Does the application support multi-region deployments for failover purposes? Have you removed all single points of failure by running multiple instances of an application's components? Have all single points of failure been eliminated? A single point of failure describes a specific fault point, which if it were to fail would bring down the entire application. Single points of failure introduce significant risk, since any failure of this component will cause an application outage. Has the application been deployed across availability zones within a region? Is the application designed to use availability zones within a region? Have you performed failure mode analysis to identify fault points and fault modes? Ask yourself, have you performed this analysis? Have you planned for component level faults to minimize application downtime? Have you validated the application can operate with reduced functionality or degraded performance in the presence of a component failure? Plan for dependency failures to minimize application downtime. Have you validated the application can operate effectively in the absence of its dependencies? Monitoring and measuring application availability is vital to qualifying overall application health and progress towards defined reliability targets. And here are our statements to help us answer this question of how do you monitor and measure application health? Is the application instrumented with semantic logs and metrics? You ask yourself the question, is your application instrumented with semantic logs and metrics using APM technology such as application insights? Are application logs correlated across components? Are application logs correlated across components to ensure end-to-end system flows and component dependencies are monitored? All components are monitored and correlated with application telemetry. Are all components monitored and correlated with application telemetry? Key metrics, thresholds, and indicators are defined and captured. Have key metrics and thresholds and indicators been defined and captured for your application? A health model has been defined based on performance, availability, and recovery targets and is represented through monitoring dashboards and alerts. Has a health model been defined to qualify what healthy and unhealthy states represent across all application components in a measurable and observable format? And is this health model fully represented through monitoring and dashboards and alerts? Azure Service Health events are used to alert on applicable service level events. Have Azure Service Health events been integrated to alert on applicable service level events? Azure Resource Health events are used to alert on resource health events. Are Azure Resource Health events used to alert on resource health events? An appropriate threshold for resource unavailability must be set to minimize signal to noise ratios so that transient faults do not generate an alert. For example, configuring a virtual machine alert with an unavailability threshold of 1 minute before an alert is triggered, monitoring long-running workflows for failures. Do you monitor any long-running application workflows and operationalize failure scenarios? Okay, in this module we covered designing for reliability, and testing for availability and resiliency. This concludes Module 5. We will take a quick 10-minute break and start back with our final module, cost optimization. Welcome back from the break. Our final pillar is cost optimization. Let's get started with Module 6. With the Microsoft Azure well-architected framework, you can build workloads with confidence based on proven deep technical guidance that is actionable and simple to use and helps you identify areas of improvement and where to focus workload optimization efforts. The framework is at the center of an ecosystem of best practices, documentation, assessments, reference architectures, and design principles. All this is supported and amplified by partners and services offering to guide you towards improving workload quality. The Azure well-architected framework enables you to achieve your business objectives, operationalizing how to design, build, and optimize your cloud solutions. The Microsoft Azure well-architected review provides and evaluates workloads with gap analysis and identifies areas of where to focus your optimization efforts. Reference architectures help you to build and deploy any workload to scale and meet your business needs. Design principles based on proven practices and design patterns from successful customer and partner deployments. Microsoft partners and services offer support to you and can help you build effective cloud solutions. After touching on Microsoft Azure's well-architected framework, let's dive right in. Research demonstrates that cost optimization is a key point of focus for customers. We've heard from many of our customers that cost optimization is one of the top IT priorities at their organizations once again. The global health pandemic has put a new focus on financial rigor and ensuring dollars are well spent. Flexera's 2021 State of the Cloud report shows that this is true across the industry, and optimizing spend has been the top cloud initiative for 5 years running. Let's look at an example of a customer engagement to see cost optimization in action. H&R Block is a good example of how customers can optimize their Azure investment and maximize their usage of Azure services. And we can see here the situation, the solution, and the impact that cost optimization has had on H&R Block. As a leader in the effort to modernize the tax industry, they wanted to optimize their cloud infrastructure and provide better service for their customers. By engaging with the Microsoft account team and operationalizing conceptual pillars of the Azure well-architected framework, the company was able to optimize its investment, re-platform into cloud-native services, and modernizing its operating models. The impact is that they're now equipped to take control of their monthly spend, and they're able to move their total compute to the cloud, using its capabilities to benefit its business and customers. You can see here we have a quote from Director of Cloud at H&R Block, Paul Clark, who states, "Our monthly spend year over year is nearly flat, while we now have approximately 30% more of our total compute in the cloud. Thanks to our partnership with Microsoft, our team has learned valuable techniques and strategies to continue optimizing our spend." Let's dive deeper into what this pillar provides and how it can help you build and manage high-performing workloads. We'd like to conduct an engagement with you to help you manage and optimize your Azure costs and become more efficient with your Azure footprint. Cost optimization is always important, but now more than ever. The purpose of this engagement would be to answer frequently asked questions from customers. Why is my bill so high? Where am I spending the most? I was told the cloud was going to be cheaper. What happened? Can I move to PaaS or modernize to reduce cost? How do I get my organization to think differently, to have cost awareness as part of their DNA? How do I provide visibility to my business units on their spending? The goal is to help you become more efficient so you can be more successful in the cloud and ultimately choose the cloud for more of your workloads. The 3 buckets of areas on the screen are where we'll focus. First, understanding your cost. Then, cost optimizing your workloads. And finally, helping you put in place practices to control your costs going forward. Here are some of the tactical things we'll end up doing together if you agree to proceed with us. Right-sizing your environment. Identifying unused orphan resources. Getting more density with your compute. Identifying reservation, hybrid benefit, and spot VM opportunities. Identifying workloads that can move up the Azure stack, using PaaS and SaaS, for example. Let's review this pillar's guiding principles. Keep within the cost constraints, aim for scalable costs, pay for consumption, right-sizing resources, and monitoring and optimizing. Let's look at a few of them in more detail, starting with the cost optimization principle, monitoring and optimize. The monitor and optimize principle states that you should treat cost monitoring and optimization as a process rather than a point-in-time activity. What does that mean? Let's discuss some specifics. Conduct regular cost reviews and measure and forecast the capacity needs so that you can provision resources dynamically and scale with demand. Review the cost management recommendations and take action to optimize workload costs. Use Azure Advisor Score to identify the greatest opportunities for cost optimization for your workload. Set budgets and alerts. A cost-effective workload is driven by business goals and the return on investment while staying within a given budget. The principles of cost optimization are a series of important considerations that can help achieve both business objectives and cost justification. Responding to alerts. When you receive an alert, check the current consumption data. Budget alerts aren't triggered in real time. There may be a delay between the alert and the current actual cost. Look for a significant difference between cost values when the alert happened and the current cost. Next, conduct a cost review to discuss the cost trend, possible causes, and any required action. For information about stakeholders in a cost review, see the cost reviews. Revise your budgets based on analysis of spending data. After you identify and analyze your spending patterns, you can set budget limits for applications or business units. You'll want to assign access to view or manage each budget to the appropriate groups. Setting several alert thresholds for each budget can help track your burn down rate. Auto-scaling. In Azure, it's easier to grow a service with little to no downtime against downscaling a service, which usually requires deep provisioning or downtime. In general, opt for scale out instead of scale up. For certain application capacity requirements may swing over time. Auto-scaling policies allow for less error-prone operations and cost savings through robust automation. For auto-scaling, consider the choice of instance size. The size can significantly change the cost of your workload. Stateless applications. Many Azure services can be used to improve the application's ability to scale dynamically, even where they may not have been originally designed to do so. For example, many ASP.NET stateful web applications can be made stateless. Then they can be auto-scaled, which results in cost benefit. You store state using Azure Redis Cache or Cosmos database. As a backend session state stored through a session state provider. Reservations. Azure reservations are offered on many services as a way to lower cost. You reserve a prepaid capacity for a period, generally 1 or 3 years. With reserved instances, there's a significant discount when compared with pay-as-you-go pricing. You can pay upfront or monthly. Price-wise, both are the same. Now let's discuss the right resources and the right size principle. Every design choice has cost implications. Before choosing an architectural pattern, Azure service or a price model for the service, consider the budget constraints set by the company. As part of design, identify acceptable boundaries on scale, redundancy, and performance against cost. After estimating the initial cost, set budgets and alerts at different scopes to measure the cost. One of the cost drivers can be unrestricted resources. These resources typically need to scale and consume more cost to meet demand. Cost modeling. Cost modeling is an exercise where you create logical groups of cloud resources that are mapped to the organization's hierarchy and then estimate costs for those groups. The goal of cost modeling is to estimate the overall cost of the organization in the cloud. An inappropriate or misconfigured service can impact cost. For example, building a multi-region service when the service levels don't require high availability or geo-redundancy will increase costs without any reasonable business justification. Certain infrastructure resources are delivered as fixed-size building blocks. Ensure that these blocks are adequately sized to meet your capacity demand, deliver expected performance without wasting resources. As requirements are prioritized, costs can be adjusted. Expect a series of trade-offs in the areas that you want to optimize, such as security, scalability, resilience, and operability. If the cost to address the challenges in those areas is high, stakeholders will look for alternate options to reduce cost. There might be risky choices made in favor or a cheaper solution. Overall service level agreement, SLAs, recovery time objective, RTO, and recovery point objective, RPO, may lead to expensive design choices. If your service SLAs, RTOs, and RPOs times are short, then higher investments is inevitable for high availability and disaster recovery options. For example, to support high availability, you choose to host the application across regions. This choice is costlier than single region because of the replication cost or the need to provision extra nodes. Data transfer between regions will also add cost. If the cost of high availability exceeds the cost of downtime, you can save by using Azure Platform Managed Replication and recover data from the backup storage. Locating resources in a cheaper region should not negate the cost of network ingress and egress or by degraded application performance because of increased latency. An application hosted in a single region may cost less than an application hosted across regions because of replication costs or the need for extra nodes. Now, let's discuss the process of cost optimization. Every design choice has cost implications. As you design the workload, consider trade-offs between cost optimization and other aspects of the design, such as security, scalability, resiliency, and operability. As part of design, identify acceptable boundaries on scale, redundancy, and performance against cost. Managed services offer cost savings as well as built-in scaling. For example, instead of running web apps on IIS, use Azure App Services. Likewise, instead of hosting a database server, consider using Azure SQL or Azure Cosmos DB. Adopt the leasing model instead of owning infrastructure. Azure offers many SaaS and PaaS resources that simplify overall architecture. The cost of hardware, software, development, operations, security, and data center space is included in the pricing model. Azure Dev Test subscription types are suitable for experimental or non-production workloads and have lower prices on some Azure services, such as specific VM sizes. If you can commit to 1 or 3 years, consider subscriptions and offer types that support Azure reservations. The Azure Architecture Center has many reference architectures and implementations that can serve as a starting point. Only deploy to multiple regions if your service levels require it, for either availability or geo-distribution. Data going out of Azure data centers can add cost because pricing is based on billing zones. Use Azure Content Delivery Network or CDN and caching services to reduce load on front-end servers. Caching is suitable for servers that are continually rendering dynamic content that doesn't change frequently. Let's walk through the Azure Well-Architected Review and how its guided technical questions can help you optimize the quality of your workloads. The Well-Architected Review provides technical guidance using directed questions to assess your workload's operational capabilities and offer guidance for the next steps of improving your workload's quality. It's very important you sign in with your Azure subscription information to save and track your progress, and to incorporate any recommendations already available in Azure Advisor to have a complete view of all the areas you can improve to have a well-architected workload. Let's walk through some of the questions related to cost optimization. These are the questions for cost optimization in the Well-Architected Review. We have selected 3 to walk through with you during the session to show how it's done, what's needed to answer them, and get the proper guidance. There are 9 questions in cost optimization, and all of them are important. We are just choosing a sample here for reference. At any point, you may click View Guidance, and that will bring you to the report with the recommendations and guidance based on your responses and the information imported from the Azure Advisor. Now let's walk through each of these questions. Lifecycle costs of enterprise solutions are a primary focus of our customers. What are your organization's process for establishing or staying within your allocated budget? How does that apply to the workloads you are assessing? Cost modeling is an exercise where you determine the lower and upper bounds of costs for your workload. Customers also align these workload costs to logical groups of cloud resources that are mapped to the organization's hierarchy. For this workload, have you estimated or are you tracking costs? How familiar are you and your team about various pricing models? Does your organization have in place appropriate governance about expenditure? Consider these choices from the perspectives of your workload while answering this question. So as you're reading these questions, in each question, it's important that you select all options that may apply. Also, there are tooltips. There's a tooltip feature in the web experience so customers can understand more about each option. And if you select none of the above, this will not impact the final score negatively, but it will provide proper guidance for modeling cloud cost. Cost modeling is an exercise where you create logical groups of cloud resources that are mapped to the organization's hierarchy and then estimated costs for those groups. The goal of cost modeling is to estimate the overall cost of the organization in the cloud. And so here are some of our assumptions or our statements under this question of how you are modeling cloud costs. Cloud costs are being modeled for this workload. Modeling allows you to identify opportunities to reduce overall cost. Estimate and track costs, educate employees about the cloud and various pricing models, and have appropriate governance regarding expenditures. Use cost management tools to plan and track costs, tag resources, and track that back to costs. The price model of the workload is clear. As part of driving a good behavior, it is important to understand what the price of a service consists of and that the cost is transparent and fair to the user of that service. Critical system flows through the application have been defined for all key business scenarios. Understanding critical system flows is vital to assessing overall operational effectiveness, and it should be used to inform a health model for the application. It can also tell if areas of the application are over or underutilized and should be adjusted to better meet business needs and cost goals. Is there a well-understood capacity model for the workload? A capacity model describes the relationships between the utilization of various components as a ratio to capture when and how application components should scale out. For instance, scaling the number of application gateway V2 instances may put excess pressure on downstream components unless also scaled to a degree. When modeling capacity for critical system components, it is therefore recommended that an N+1 model be applied to ensure complete tolerance to transient faults, where N describes the capacity required to satisfy performance and availability requirements. This also prevents cost-related surprises when scaling out and realizing that multiple services need to be scaled at the same time. Internal and external dependencies are identified and cost implications are understood. Examples of typical dependencies include platform dependencies outside the remit of the application, such as Azure Active Directory, ExpressRoute, or a central network virtual appliance, as well as application dependencies such as APIs, which may be in-house or externally owned by a third party. It's important to understand the cost for these services and how they are being charged. This makes it easier to understand an all-up cost. Cost implications of each Azure service used by the application are understood. It is important to understand what Azure services, such as app services and event hubs, are used by the application platform to host both application code and data. In a discussion around cost, this can drive decisions towards the right replacements. In other words, moving from virtual machines to containers to increase efficiency, or migrating to .NET Core to use cheaper SKUs. The right operational capabilities are used for Azure services. Operational capabilities such as auto-scale and auto-heal for app services can reduce management overheads, support operational effectiveness, and reduce cost. Make sure you understand the operational features and capabilities available and how they can be used in the solution. Special discounts given to services or licenses are factored in when calculating new cost models for services being moved to the cloud. When alternative cost options are considered, it should be understood first if any special offers or deals are given for the existing SKUs to verify that the correct prices are being used to build a business case. Azure Hybrid Use Benefit is used to drive down costs in the cloud. Understanding your current spending on licenses can help you drive down costs in the cloud. Azure Hybrid Benefit allows you to reuse licenses that you purchased for on-premises in Azure, and via this drive down the cost as the license is already paid. Let's look at how you are monitoring your cloud costs. Monitoring is a key activity across being and remaining well-architected across your workloads. Monitoring your costs to stay within your allocated budget and drive positive return on investment for your enterprise workloads with predictable cost. Do you consider cost metrics for each resource in the workload? Are you working to establish for each metric alerts on baseline thresholds? Have you established your cost budget amounts, time periods, and email alerts? Like any systems monitoring, this may need refining over time. Some increase in operational costs might outweigh business value delivered by your workload. Do you perform cost reviews on a regular cadence and include your key stakeholders for workloads already deployed or shared infrastructure that your workload will leverage? Do you have access to and review Azure Advisor cost recommendations? Consider the business value generated against these options while answering this question. How are you monitoring cost of this workload? Consider the metrics for each resource in the workload, and for each metric, build alerts on baseline thresholds. Now let's look at the statements. Alerts are set for cost thresholds and limits. This is to ensure that if any budget is close to the threshold, the cost owner gets notified to take appropriate actions on the change. Specific owners and processes are defined for each alert type. Having well-defined owners and response playbooks per alert is vital to optimizing operational effectiveness. For example, the budget owner should be made aware of capacity issues so that budgets can be adjusted and discussed. Application performance management tools and log aggregation technologies are used to collect logs and metrics from Azure resources. In order to successfully maintain the application, it's important to turn the lights on and have clear visibility of important metrics both in real time and historically. Log aggregation technologies, such as Azure Log Analytics or Splunk, should be used to collate logs and metrics across all application components for subsequent evaluation. Resources may include Azure Infrastructure as a Service and Platform as a Service services, as well as third-party applications such as firewalls or anti-malware solutions used in the applications. For instance, if Azure Event Hub is used, the diagnostic settings should be configured to push logs and metrics to the data sink. Understanding usage helps with right sizing of the workload, but additional costs for logging needs to be accepted and included in the cost model. Cost management tools such as Azure Cost Management are being used to track spending in this workload. To track spending, an Azure Cost Management tool can help with understanding how much is spent, where, and when. This helps to make better decisions about how and if costs can be reduced. Let's walk through how you are ensuring that your cloud services are provisioned appropriately. Provisioning or deploying your resources correctly from day zero is critical, not only for the proper operation of the solution or workload, but also for managing associated costs. The automation that your organization has in place for provisioning your workload has implications on your overall cost. Deployment of cloud resources of a workload is known as provisioning. Does your organization invest in automation based on the lifespan and business value of your workload? Are there existing investments in continuous integration and continuous deployment that you can leverage for your workload? Is your workload's capacity and scaling considerations automated? Do you have plans in place to periodically review and right-size the SKUs for the services your workload leverages? What is your organizational appetite for choosing appropriate services when your business requirements change? Choose these considerations from the perspective of your workload while answering this question. Performance requirements are well defined. Non-functional performance requirements, such as those relating to end-user experiences, in other words, average and maximum response times, are vital to assessing the overall health of an application. From the cost perspective, it's recommended to set a budget for extreme circumstances and indicate upper limit for cost when it's not worth serving more traffic due to overall cost. Targets for the time it takes to perform scaled operations are defined and monitored. Scaled operations, horizontal changing the number of identical instances, and vertical scaling, which is switching to more, less powerful instances, can be fast, but usually take time to complete. It's important to understand how this delay affects the application under load and if degraded performance is acceptable. The workload is designed to scale independently. If the workload contains multiple components and one component requires scale, this triggers scale out or up of the entire infrastructure. It needs to be evaluated if the application scale is monolithic or each component is scaled independently, and for example, how the database scales with the rest of the workload. The application has been designed to scale both in and out. Azure provides elastic scalability. However, applications must leverage a scale unit approach to navigate service and subscription limits to ensure that individual components and the application as a whole can scale horizontally. Don't forget about scale in as well, as this is important to drive costs down. For example, scale in and out for app services done via rules. Often customers write scale out rule and never write a scale in rule. This leaves the app service more expensive. Application components and data are split into groups as part of your disaster recovery strategy. A disaster recovery strategy should capture how the application responds to a disaster situation, such as a regional outage or the loss of a critical platform service, using either a redeployment, warm spare active passive, or a hot spare active active approach. To drive down costs, consider splitting application components and data into groups. For example, must protect, nice to protect, ephemeral can be rebuilt, lost instead of protecting all data with the same policy. Tools such as Azure Advisor are being used to optimize SKUs discovered in this workload. Azure Advisor helps to optimize and improve efficiency of the workload by identifying idle and underutilized resources. It analyzes your configurations and usage telemetry and consolidates it into personalized, actionable recommendations to help you optimize your resources. Resources are reviewed weekly or bi-weekly for optimization. Your underutilized resources need to be reviewed often in order to be identified and dealt with accordingly, in addition to ensuring that your actionable recommendations are up to date and fully optimized. For example, Azure Advisor monitors your virtual machine usage for 7 days and then identifies low utilization VMs. Cost-effective regions are considered as part of the deployment selection. Is there a technical or legal reason for deploying in a particular region? If not, it might be worth looking at another region to decrease cost. Also, depending on the workload and data processing model, choosing a cheaper region might make more financial sense. Dev test offerings are used correctly. Special SKUs and subscription offers for development and testing purposes can save costs, but have to be used properly. Dev SKUs are not meant for production deployments. Shared hosting platforms are used correctly. Do your application components leverage shared data platforms such as a central data lake or application hosting platforms such as a centrally managed AKS or ASC cluster? Shared platforms drive down cost, but the workload still needs to maintain the expected performance. At this point, let's open the final Q&A session. What are the next steps for you? Get hands-on and assess your Azure workloads with well-architected review. Leverage the recommendations from Azure Advisor. Continue to learn about this framework and the best practices in MS Learn. This concludes our Microsoft Azure Virtual Training Day, Well-Architected Framework. Let's recap what we have seen. Operational excellence. We took a look at making sure that you are using the right tools for the right job. Reliability strategies. These are strategies that make sure that your applications have a high availability and resiliency to failures, as well as cost optimization, making sure that you don't overspend or underspend in your utilization of your resources. Thank you for attending the Microsoft Azure Virtual Training Day, Well-Architected Framework. Remember, there are many ways to continue your Azure learning journey, such as MS Learn, where we offer self-paced learning options. Happy studying.